Hi, in the previous video, we tried to understand what is ARM and what are the applications of various ARM processor cores. All right. Now, in this video, let's try to understand the complete range of ARM processor cores that are available to meet the requirements of various applications. All right. So let's look into ARM Cortex processor cores that are available. So basically, ARM processor cores, which will be under Cortex family, can be divided into three main families: Cortex A, Cortex R, and Cortex M. This is how ARM will release their processor IPs under different profiles like A profile, R profile, and M profile. So you might have already heard about the processors like Cortex A53 or Cortex A7 or A53 or A73, similarly Cortex M0, M1, right? So all these are the processor cores that are available from ARM, which will be under any one of these families. So let's try to understand what are these families. We also call them as profiles. So what is A profile, what is R profile, and what is M profile? Let us try to understand. All right. So as we have discussed earlier in the previous video, ARM processor cores are available in such a way that they can be used in any kind of applications. We have different kinds of ARM processor cores that can be used in small embedded application, and similarly we have high-end processor cores from ARM which can be used in high-speed servers. Right? So that way, ARM company has released processor cores to meet the requirements of various applications, which will be under any one of these families. Right? So if you look at the Cortex A family contains the processors that are capable of running complex operating system and even third-party applications. Right? So if you look at the Cortex A family processors, they are capable of running multiple applications simultaneously, and they are even capable of running complex operating systems such as Linux and Android, iOS, etc. So the A profile processors are capable of delivering better performance so that they can be used in high-end applications such as mobile phones, tablets, and laptops. And the next category of Cortex processors are Cortex R family. So the processors which will come under this R family can be used for processing real-time signal data, something like memory controllers or even Wi-Fi routers, networking components, where they need to deal with large data. At the same time, they need not really run complex operating systems. So for these kind of applications, we can use Cortex R processors. And similarly, for small microcontroller-based embedded applications, we can use Cortex M series processors. So these processors are pretty simple processors so that they can be used in tiny gadgets, right? Or even home appliances. So wherever you wanted to design an embedded-based application using a processor, then that kind of processor need not really run complex operating systems and they need not really deliver better performance. Mid-range performance and lesser power consumption are good enough for embedded applications. That's where we can prefer Cortex M family processors. So that way, ARM company has developed so many processors to meet the requirements of many applications. So under each family, we have multiple types of processors, which will vary in terms of power consumption, performance, and some more features, right? So let's look into these processor families in detail in the later slides. All right. I hope with this, you people have got fair idea on different families like A, R, and M. All right. Now let's look into architecture versions and profiles. So already we have seen different profiles like A profile, R profile, and M profile. Now let's look into the versions of ARM architectures. All right. So the popularity of ARM has begun from the version 4. So V4T is the starting version from which ARM started gaining its popularity. So you might have already heard about ARM7 TDMI, which has got huge reputation for ARM, right? So ARM7 TDMI is belonging to this particular version, V4T. So V4T version supports all the instructions and all the features from version 3. Along with that, it supports half word, signed half word, and even byte supports for various instructions. And similarly, it supports thumb instruction set as well. So before V4T version, all the instructions in ARM are of 32-bit wide. Every instruction is of 32-bit wide. But from V4T, they got a new instruction set called thumb instruction set. So when it comes to thumb instruction set, all the instructions are of 16-bit wide. So that way, from V4T, here T stands for thumb. They have added support for half word, signed half word, and byte instructions. At the same time, thumb instructions and even system mode to enable protection. All right. So from the V4T version, the next version is V5. So the V5 version has got all the features from V4. Along with that, they have added some more features, like it has got saturated arithmetic instructions, which will be used in vector processing. Right. Similarly, we have multiply and accumulate instructions, which is very useful in the DSP applications. And similarly, they have improved the previous thumb instruction set so that from V5 version onwards, we can make use of regular ARM instructions and the thumb instructions, a combination of both the instructions in a single program, right? So that way, all these things have been added in V5 version, all right? Along with that, from V5 version, they have added optional extensions. So these extensions are not mandatory features. If you want, you can enable them, right? So one of the extension that is supported in v5 is Jezzel extension, which contains Java-based instructions. All right. And from v5, the version 6 has been developed, which contains all the features that are there in v5, plus additional instructions like SIMD instruction, single instruction, multiple data, which is very much needed in image processing kind of applications. And similarly, v6 supports multi-processing, simultaneous multi-threading, right? And even memory architecture has been further improvised, and it has even got support for unaligned data support. So where the address of the data transfer need not be aligned. Along with that, some more new extensions are supported, like Thumb2, improved Thumb version, and Trust Zone for improving the security, and multi-core, which means dual core or quad core or octa core processor systems can be implemented starting from v6 version. And we can even design v6 architecture which supports only thumb instructions. It need not be a combination of both ARM and thumb, right? So that way v6 version has been developed. And from v6, v7 version has been developed, which contains all the features that are there in v6, plus additional features like Thumb2. Thumb2 is an improved version of the regular thumb instruction set. Along with that, from v7 onwards, ARM started developing profiles like A profile, R profile, and M profile to meet the requirements of various applications. So that way we have got different versions. And from v7 onwards, we have got different profiles as well, A, R, and M profiles, right? So if you consider the processors like Cortex A8 and Cortex A9, both the processors are based on ARM v7A profile, ARM v7A profile, but their internal design will be slightly different. If you look at Cortex A8, it contains a 13-stage pipeline architecture, and Cortex A9 contains an 8-stage pipeline architecture, which means there will be some differences in terms of performance because of the difference in the number of pipeline stages. But since both the processors are based on v7A architecture, the instruction set will be same for both architectures, and the software that you have developed for Cortex A8 will work even in Cortex A9 as well, because both will work on same instruction set, because they both same architecture, v7A architecture. All right. This is how we have got different versions and different profiles in ARM. All right. Now, as we have seen, starting from version 5, version 6 has been developed, and from there version 7 has been developed, from which we got the profiles like A, R, and M, so that all the features that are there in v5 will be there in v6 as well, plus some additional enhancements, right? And starting from v8A, they have divided into two architectures. Until v7, all the ARM architectures are of 32-bit wide, but starting from v8, they have got the ARC32 version as well as the ARC64 version, so that we will have both 32-bit variants of v8A processors as well as 64-bit variants of v8A processors. All right, this is how we have got different versions. And under each version, we have got different processors. As we have seen, the Cortex A5, A7, A8, A9, all these are belonging to v7A architecture itself. But as I have discussed earlier, they vary in terms of number of pipeline stages, etc. All right. So that way you can find different processors under different families or different profiles. Even under Cortex v7M, we have Cortex M3, M4 as well. And the popular Cortex M0 is from ARM v6M profile. All right. Now, how to make use of different kind of processors to make a complex system. As you can see here, if you look at our mobile phone, it contains the main processor, application processor, which will be built based on A profile, and even some graphic processing units will be used. But for other things like Bluetooth stack and even Wi-Fi stack, we can make use of either M series processor or R series processor. Similarly, for the GPS modem, we can make use of Cortex M series processor. In that way, all the other peripherals and their software stacks can be managed by different versions of Cortex processors. This is how, by making use of different kinds of processor cores, a complex system like a mobile phone can be built. All right. So I hope with this, you people have got some fair idea on the different versions of ARM and different profiles that are there for ARM architectures. All right. In the next video, we will try to understand a little more about ARM architecture.